Hi and good morning, Salim. My name is MONESWARRAN and I like GUNASEGARAN. Today, I, along with my group members, are going to present our group project of Artificial Intelligence DAT21003. So, what is K-means? K-means is a type of unsupervised machine learning technique used to tackle clustering problems in machine learning and data science. It is the one of the basic and widely used unsupervised machine learning algorithm. The K-means algorithm determines a set of K clusters and assign each example to exactly one collection. The cluster consists of similar examples. The similarity between examples is based on distance measured between them. K-means clustering is a vector quantization approach that seeks to split an observation into K clusters. As as you can see, sir, this is our result after doing our group project using a K-means clustering algorithm. Next, what is a UCR repository? UCI Machine Learning Repository is a collection of database, domain theory, and data generator used by the machine learning community for the empirical analysis of machine learning algorithm as a primary source of machine learning dataset. So I'm going to show to sir how to obtain a machine learning, a Router 5050 dataset from the internet. First, tap the Router 5050 dataset. Then click the first result. It will redirect us to a new page. After that, click download data folder. The data folder will download it as a zip file. After downloading the zip file, we need to extract all the content into a new normal file. So this is the content of C50 related dataset. There are two folders, C50 test and C50 train. Inside C50 test and C50 train, there are a lot of classes. So in this group project, we are going to take only the top 4 classes in the C50 test, which are Aaron Pressman, Alan Cusby, and Alexander Smith, and Benjamin Kangling. Before that, before we use this class in our text processing operator in rapid manner, we need to create a new folder in rapid manner local repository. Okay, first we need to create a new folder. We can name the folder as project data. After successfully created the project data file, we need to copy the classes that we are including in our group project. Then we need to paste all the classes to the newly created file, which is project data. Yes, sir, we are successfully created. We are successfully copied the 4 classes that we are using in our group project. So that's all from me, sir. Thank you. Next service will continue about text processing operator such as tokenize and transform case operator. Thank you.
Thank you, Monish, for the wonderful presentation. Hello and a very good morning, sir. My name is SARVEISH and my metric number is AA200877. In this video, I would like to explain the design and also the process view regarding the process document from files operator. As you can see, this is the process view. In this process view, we have added 1, 2, 3, 4, 5, 6 operators that are able to produce k-means algorithm and also result and display the appropriate result. On this wonderful day, I would like to explain the process document from files operator and also the operators within this operator. First of all, the process document from files operator contains 6 parameters which are text directories starting from Aaron Pressman till Brad Dorfman. So we also set the vector creation to term frequency inverse document frequency. This often used as a weighting factor in information retrieval and text mining. So now let's enter into the design view of process document from files operator. As you can see, there are 7 different and unique types of operators within it. First of all, extract content operator. In this operator, the content from the documents which are sent as a parameter will be extracted and the information will be gathered. Later on, it will be sent and transmitted to the tokenized operator. In this operator, it divides the string sequence from the documents from each document into tokens. Later on, it will be passed towards the WordNet operators, which can be named as find synonyms WordNet operator and also open WordNet dictionary. In order to find synonyms to work, it needs a WordNet dictionary. In order to provide the WordNet dictionary as the input, open WordNet dictionary operator will be used. As you can see, the parameter of the open WordNet dictionary will be the file path of the dictionary which is stored in my laptop. Later on, the input will be sent into the find synonyms WordNet. In this find synonyms operator, it will find the synonyms of each token that is passed towards it. Later on, it will be transmitted to its transform cases operator. In this operator, each token or each text will be transmitted or converted into lowercase as per the parameter is set towards lowercase over here. Later on, it will be transmitted to filter stopwords operator that covers English language. As you can see, it helps to remove all English tokens equal to a stop word from the given token file. Example of stop words are the, and so on. Finally, the uh, the filtered tokens will be transmitted into stem operator that uses Porter algorithm. It helps to eliminate and remove grammatical ends in English words of the tokens or documents using Porter's stemming algorithm. For an example, listening or listened will be converted into base or root word, which is listen only. Now, as you can see, these two operators are optional as it will improve the efficiency and also the accuracy result of the performance if these two operators are getting disabled or other mean is without WordNet. The result will be displayed once all of the operators over here are successfully executed. The operators starting from data to similarity till performance operator will be explained thoroughly by my other teammates, and also the result also will be explained thoroughly by my teammates as well. So that's all from me, sir. Thank you.
Hi, I am Farah. We continue from the SARVEISH part, which is the demonstration of the rapid miner. In the previous part, SARVEISH already explained the process document operator that consists of extract content, token, find synonym WordNet, transform case, filter, open WordNet, and last but not least is a stem. But now I will explain the other five operator, which is 6, which is data similarity, clustering, map clustering, apply model, performance. Yeah, that's all 5 operators. Okay, all of these operators we can get on the left side of the rapid miner. Just search, for example, is the data similarity. Here is it. Okay, I drag into the word session. Next is clustering. Okay, just choose the first one, which is the k-means, and put it on the scene, and then is mapping, map clustering. clustering, also boleh tanda ni ada workspace, apply model, take it into here, and last but not least, the last operator is a performance. Performance, we take the first one, which is the classification, and put all of this in the workspace, and then connect all of them, which is the data similarity we connect with the operator process documents, clustering connected with the data similarity. Also, the data similarity need to be connected with the final resources, and then clustering connect with map clustering, then apply models, and last but not least performance. At the end of the resources, there is two, which is data similarity and performance. Okay, now delete all of this. Delete because we want to run it. Okay, now I will run the process to show the result. Okay, it takes a quiet time because there is 4 data set that we need to process, and in this previous parts also already lot of operator. Just take a moment. Okay, already in the clustering. Okay, so this is the similarity measure object because we apply operator data to similarity. We can see the first, second, and the similarity between it. Also, we can see in the graph performance and histogram. Okay, and then for the performance factor, the accuracy, we can see in the table view, and at the right side of the tables, it show the class basis. The accuracy of all of these dataset is for 53.76, and also we can view in a plot view, this one. Okay, now I'll be back to the design and I will explain all of these 5 operators functions. First thing is a data similarity. Data similarity. The data in similarity is operator that calculates the similarity among the example of an example set. Next is a clustering. Clustering, or better known of k-means, as we choose before. Clustering perform a random flat clustering of the given example set. Clustering is concerned with grouping objects together that are similar to each other but distinct the object in other cluster. Okay, the second one is the third one is map clustering. Map clustering is a operator that converts the cluster attributes into a prediction attributes. The map clustering on label operator takes the input, a cluster example set on the cluster set, and a cluster model. It is estimate mapping between the specified clustering and prediction using this input. Okay, the third one and the fourth one is apply model. Apply model is another operator that we use in this project. It is usually a learning algorithm. First train a model on an example set. This model may then be applied to another example set. Typically, the purpose is to make a forecast based on previously unknown data or to alter data using a pre-processing model. And lastly is a performance. Performance is a operator that used to access performance, return to a list performance creation value. These performance standards are set off automatically based on the kind of a learning task. All of these, and another one I want to explain is a k-means algorithm. What is k-means algorithm actually? And when we search here, k-means, you can see there is a lot of k-means here. K-means operator use and division. Okay, the k-means algorithm means to determine a set of k cluster and assign each examples to except one cluster. The cluster consists of similar example. The similarity between example is based on distance measure between them. Okay, that's all from me. Thank you. I will pass to the next presenter.
Result of comparison in terms of performance vector in task 8. The accuracy of k-means in each precision class between WordNet and without WordNet differs in terms of performance accuracy percentage, which is the percentage of performance without WordNet is higher than with WordNet. The k-means with WordNet is 78.50% and k-means without WordNet is 90.50%. We also can see the differences of percentage of each class is different in class precision and class recall with WordNet and without WordNet. The reason is because the WordNet-based measure of similarity may compete with embedding-based approaches in the task of text document clustering, and the percentage is higher because the frequent word can capture in the class more precisely.
Hi, I am Narufashamla with the RADZI matrix number AA200782. The output will be displayed as two separate viewpoints of the four documents. Firstly, the performance vector. It is a list of performance criteria values. The performance vector is calculated on basis of the label attitude and the prediction attribute of the input example set. The accuracy performance for without WordNet is higher than with WordNet, which is 90.50%, while with WordNet is 78.50%. Secondly, in terms of similarity measure object, Figure 19 shows the graph of similarity measure object result with WordNet operators, while Figure 18 shows the graph of similarity measure object result without WordNet operator. The graph with WordNet operator shows a persistent result compared to without WordNet. Since WordNet it is used to generate synonym words of each word piece from the sentence by using the WordNet dictionary.